We're about to pull back the curtain on a piece of tech you probably use every single day without even knowing it. It's got this kind of complicated sounding name, naive Bayes, but I promise you, the idea behind it is incredibly simple, and honestly, it's surprisingly powerful. So, let's just dive right in. Think about your email inbox. It's a classic problem, right? You open it up, and somehow, most of the junk is already tucked away where it can't bother you. How does your email know the difference between a real message from a friend and some ad screaming about a secret prize? Well, turns out it's not magic at all. The secret weapon here is something called a classifier. You can think of it like a digital gatekeeper for your inbox. Its entire job is to look at every single message and make a super quick judgment call. Is this important or is it junk? But how does a computer program learn to do that? All right, so to really get this gatekeeper, we first need to understand the basic idea it uses to make these decisions. And you might be surprised to hear it doesn't rely on some super complex set of rules. Instead, it just plays a simple game of chance. And that brings us to the Bayes part of naive Bayes. See, it's all built on a core idea from math that you're probably already familiar with, even if you don't call it by its formal name. We're talking about probability. At its heart, probability is just a fancy way of asking a really simple question. What's the chance of something happening? What's the chance it's going to rain today? What's the chance you'll roll a 6? Or, for our purposes, what's the chance this email is spam? And the math is actually super straightforward. Imagine a bag with 12 marbles, and 7 of them are red. The probability of picking a red one is just 7 out of 12. It's the number of ways you can get what you want, divided by the total number of things that could possibly happen. Simple, right? And that's exactly the logic naive Bayes uses. The algorithm gets fed thousands and thousands of old emails. Some are spam, some aren't. And by looking at all of them, it learns to calculate the probability for any new email and make a really, really good guess about which pile it belongs in. Okay, so we've got the Bayes part down. That's all about probability. But what about the naive part? This is where things get really interesting. This is the algorithm's clever little secret. Now, you might think naive sounds like a bad thing, especially when we're talking about smart technology. But in this case, it's actually the algorithm's superpower. It's the very thing that makes it so fast and so efficient. It's called naive because it makes one huge simplifying assumption. It assumes that all the different pieces of information it's looking at, in our case, all the words in an email, are completely independent of each other. So get this. The algorithm doesn't care that the phrase secret party is probably an invitation from a friend. It just sees the word secret and thinks, that's a point for the spam pile. Then it sees the word party and thinks, okay, that's a point for the not spam pile. It treats every single word like a separate clue, totally ignoring grammar, context, or the order they're in. It's a naive way to look at language, but it works shockingly well. Okay, so we've got the basic theory. Use probability and just assume all the words are separate clues. But how does that actually turn into a machine that learns to sort your email? Let's walk through it step by step. First thing you do is feed the machine a giant pile of emails that humans have already labeled as either spam or ham, which is just the fun industry term for a normal, good email. The algorithm then just crunches all that data. It builds little tables, kind of like this one, learning that words like free, win, and prize show up way more often in spam. So here's the whole process laid out. You start by feeding it all that label training data. From there, it calculates the probability for every single word it sees, learning which words are red flags for spam. All of that data builds what we call a predictive model. And once that's built, it's ready to go to work on any new email that comes its way. So when a brand new email hits your inbox and it's full of words like secret, prize, and now, the model just looks up the spam probability for each of those words. It adds them all up and sees that the total score for spam is off the charts. And just like that, it makes its final call and, poof, sends that email straight to your junk folder. At this point, you might be thinking, wait, that's it? That seems way too simple to actually work. But honestly, that's the whole beauty of naive Bayes. Its simplicity is the exact reason it's become such a huge deal in machine learning. So why is it so popular? Well, for one, it's incredibly fast. Because it's ignoring all those complex relationships between words, the math is dead simple. It's also super easy to train. And this is a big one. It often gets fantastic results with way less training data than those big, complicated models need. And this mix of speed and effectiveness makes it the perfect tool for all kinds of things. Yeah, we've been talking about spam filtering, but it's also used for things like real-time predictions, sorting news articles into different categories, and even helping power recommendation systems. And believe it or not, its power goes way beyond your inbox. This so-called naive approach is tough enough for really high-stakes fields like medicine. It helps classify diseases based on patient symptoms. And why is that? Because it's fast, and maybe more importantly, the results are way easier for doctors to actually understand than the output from some mysterious black box AI. It just goes to show you don't always need the most complex tool to solve a complex problem. And that really is the whole story here. If you remember one thing, it's this. Naive Bayes is the perfect example of a simple idea that just delivers incredibly powerful results out in the real world. Ultimately, naive Bayes proves that sometimes making a simplifying, naive assumption is actually the smartest move you can make. It kind of leaves you with a fascinating question, right? In a world that's always chasing more and more complexity, what other huge problems could we solve if we just dared to try a simpler approach?